Hi everybody, hello, welcome to another video. So in this video I want to talk to you about the Singleton pattern. On my previous video I actually coded the entire class without talking, just showing the keyboard. But now I'm going to go over the actual implementation, why I made some of those decisions. If you are looking into design patterns, you probably heard about this book before, the Design Patterns book, the Gang of Four books book actually. And I'm going to go over some of the things that they talk about it in here about the Singleton pattern as well. But first of all, let's just get started with the beginning here. So I actually have the entire class already done. I'm just going to press Control Z in here, and then I'm just going to go step by step. I hope this is going to be okay with you guys. So initially, to create a singleton, what we do here is declare a brand new class, a singleton brand new class, and I just call it singleton this time. The reason why I use the seal keyword here is that the singleton, so then the singleton cannot be inherited. It actually goes against what's written in the design patterns book, but I just personally haven't seen a need to inherit from a singleton. That's what I've done before, so that's what I'm going to share with you guys. If there's a situation where you need to inherit from the singleton class, you can just remove that keyword. The next thing that we're going to do is create a field inside the class, and this is going to be a private static singleton. This is a nullable singleton, and by convention we name that field instance. The keyword volatile here means that the compiler knows that this instance may be accessed. Multiple threads may access this instance at the same time, so it will go through the instantiation of, it will go through the initialization of the instance, and it will only return it when it is complete. That's what the volatile keyword does. The next field that we're going to use is a private static object. In this object right here, we're going to use to actually lock the instantiation of the singleton. This is really important. This right here is usually you have something like this, constructor, and most of the time constructors are public. In the case of the singleton, we're actually going to make that constructor a private constructor. That way no one can create a new instance of it by simply calling the constructor. We're making it private. Next, we're going to create a property, and that property will also be a static property, and it's going to return a singleton. That property, by convention, is named instance in C# with a capital I, and we're only going to have a getter in that property. And the first thing that we're going to do inside the property is we're going to check if this instance right here is not null, and if it isn't null, then we're going to return the instance. It doesn't make much sense because we haven't assigned a value to it yet, but we're going to do that just a little bit lower here. So now we use the lock keyword and we use that object in there. And what this does, if there are multiple threads trying to access this part of the code at the same time, like line 23, it's going to lock it, and it's not going to allow another thread to come in here until the thread that got in here first is finished. So what's going to happen is we're going to lock it. We're going to check if the instance, we already went through this check, right? So the instance was null, so it went down to the next line. And in this case, the instance is equal to null. And then we're going to create a new instance of the singleton and assign it to that field in there. And then we're going to return the field. At this point, we're returning the class, and the class created itself. Down here is just a property that I have in here just for testing purposes. Okay, so this is the singleton class. Let me just go over the book really quick. Let me see, we're like 4 minutes in. Let me just go over the book really quick. So the intent of the singleton pattern is to ensure a class has only one instance and provides a global point of access to it. So by making it private, we can control the instantiation of the class, and then there's only one global point of access to the instance, which is through the instance property right here. Okay. So this book was written a really long time ago. But the motivation over here says the motivation is important for some classes to have exactly one instance. Although there can be many printers in a system, just to give an example, there should be only one printer, a spooler. There should be only one file system and one window manager. So it's just giving some idea of when to use the Singleton pattern. A lot of times the Singleton pattern is associated with factories. And when I was reviewing the book here, at the very end, it says related patterns. It says that many patterns can be implemented using the Singleton pattern. See abstract factory, builder, and prototype. So those are other creational patterns, and I've seen mostly the Singleton being used in a factory. That's where I've seen the most. So let's just do some testing really quick. So I actually deleted the code that was written here previously. Let me go ahead and maximize this so we give ourselves a little room. I just want to explain what I did there in the previous video. So I created a variable here, so instance 1, and then at this point I'm using this Singleton right here, and I am calling that instance property. I'm going to put a breakpoint in here so we can see what happens. So now that we have that instance, I am going to assign some kind of a value to the sum value property. Sum value equals 42. And then let me create another variable that holds a reference to the Singleton instance as well. And as you can see, I haven't done anything with the instance 2. But what I'm going to do is print it out. So let me go ahead and then let's do this. And then we're going to say instance 2. Instance 2 is going to be let me go ahead and put a console.read line so then it stays there for a second. What's interesting here is that we're going to create a variable to hold the instance, and then we're going to assign a number, an integer, to the sum value property. And then we're going to create a different variable that holds a reference to the same instance. And if it is the same instance, then this sum value right here should be the same sum value that we use for instance 1. And so we're just going to print it out and take a look at that. So let's go ahead and then Singleton pattern there. So let's run it. It's over here in the other window. Let me go ahead and put this over here so I can debug it. So F11, it goes inside the Singleton. As you can see here, the instance. All right, time out. As you can see, just a second ago, I did not understand what was happening. This is the first time that we're accessing this, and it's supposed to be null, and it was already there. So I did some Googling around. I went to Stack Overflow, and there was the same question in there. When you're starting a Singleton in the Visual Studio, the instance it's already initialized, and that's because of the debugger. Okay, so the debugger is doing some optimization in the back to have the values available. So in production, when you're not debugging, that doesn't happen. So we are not going to see it going through the lock in here, but we're just going to. It's just going to be instantiated for us already, but it is the same instance. So we pull that instance, we assign a value to it, and then we're going to get the same reference, and that same reference holds the sum value that we assign on instance 1. So pretty straightforward. I just want to go through that quick exercise. And so once again, singletons are good for according to the design patterns book, are good for abstract factories, builders, and prototypes. And I'm gonna go ahead and cover factories next. So we're gonna make use of the singleton right here. All right, guys, thank you for watching. Bye-bye.